A GFCI showing no ground on a receptacle tester, while the test and reset functions work, but an external GFCI tester fails to trip it, suggests a few potential problems. Firstly, consider an open ground wire. The ground wire in the circuit could be disconnected or broken, preventing the GFCI from detecting ground faults. Secondly, incorrect wiring is a possibility. The GFCI might not be wired correctly, leading to a false ground reading on the receptacle tester, but preventing the external tester from triggering the trip mechanism. Thirdly, the GFCI itself could be defective. A faulty GFCI might fail under actual ground fault conditions, even though it seems to function correctly during self-testing. Fourthly, investigate a possible ground rod issue. The ground rod outside the home might be improperly installed or corroded, resulting in poor grounding and causing the GFCI to fail to trip. Fifthly, consider electrical noise or interference. External electrical noise or interference can sometimes affect the GFCI's ability to detect ground faults, leading to false readings. Sixthly, it could be an arc fault or a very small fault current. An arc fault or a very small fault current may not be detected by the GFCI during self-testing, but could still cause it to fail to trip during an actual electrical hazard. Keep in mind the self-test reset button on a GFCI can provide an indication that the device is functioning. It is not a comprehensive test of the entire system. It only tests the internal circuitry and does not verify the ground path or other components of the electrical circuit. To address this, firstly, inspect the wiring. Check the wiring connections to the GFCI and ensure they are secure and correct. Secondly, test with a ground fault tester. Use a ground fault tester to confirm that the ground path is complete and the GFCI is functioning properly. Thirdly, if the issue persists and the ground wire is confirmed to be intact, it is advisable to contact a qualified electrician to further diagnose and repair the problem. If all other causes have been eliminated, consider replacing the GFCI to ensure optimal protection against electrical hazards. Now let's delve into the possible causes in more detail. An open ground wire is one of the most frequent reasons why GFCI might show a lack of ground. The ground wire serves as a safety net, providing a path for stray electricity to return to the source, thus tripping the GFCI in the event of a ground fault. If this wire is disconnected at any point in the circuit, or if it is broken, the GFCI will not be able to detect a ground fault properly. This disconnection could occur at the GFCI receptacle itself, at another receptacle in the circuit, or even within the electrical panel. To check for an open ground wire, you'll need to visually inspect the wiring connections at each point in the circuit. Make sure that the ground wire, which is typically a bare copper wire or a green insulated wire, is securely connected to the ground terminal on each receptacle and to the ground bar in the electrical panel. If you find any loose connections, tighten them. If you find any broken wires, repair them using appropriate wire connectors. Incorrect wiring is another potential culprit. Even if the ground wire is intact, if the GFCI is wired incorrectly, it may not function as intended. One common mistake is to confuse the line and load terminals on the GFCI. The line terminals are where the incoming power from the electrical panel should be connected, while the load terminals are where the outgoing wires that feed downstream receptacles should be connected. If these wires are reversed, the GFCI may still power the circuit, but it will not provide ground fault protection. To verify that the GFCI is wired correctly, you'll need to consult the wiring diagram that comes with the GFCI. This diagram will show you exactly which wires should be connected to which terminals. Make sure that the line and load wires are connected to the correct terminals, and that all other wiring connections are also correct. A defective GFCI is also a possibility. Like any electrical device, GFCIs can fail over time. If the internal circuitry of the GFCI is damaged or worn out, it may not be able to detect ground faults properly, even if it seems to function correctly during self-testing. The self-test function on a GFCI only tests the internal circuitry of the device. It does not test the ground path or other components of the electrical circuit. Therefore, a GFCI can pass the self-test and still be defective. To determine if the GFCI is defective, you can try replacing it with a new one. If the new GFCI works properly, then the old GFCI was likely the problem. A ground rod issue can also contribute to the problem. The ground rod is a metal rod that is driven into the earth and connected to the electrical panel. It provides a path for electricity to dissipate into the ground in the event of a ground fault. If the ground rod is improperly installed, or if it is corroded, it may not provide a good enough ground connection. This can prevent the GFCI from tripping properly. To check the ground rod, you'll need to visually inspect it to make sure that it is securely driven into the ground and that it is not corroded. You can also test the resistance of the ground rod using a ground resistance tester. A good ground rod should have a resistance of 25 ohms or less. Electrical noise or interference can also affect the GFCI's performance. Electrical noise is unwanted electrical signals that can interfere with the operation of electronic devices. This noise can come from a variety of sources, such as nearby appliances, power lines, or even radio transmissions. If there is a lot of electrical noise in the area, it can interfere with the GFCI's ability to detect ground faults. This can lead to false readings or prevent the GFCI from tripping properly. To mitigate the effects of electrical noise, you can try installing a noise filter in the circuit. You can also try moving the GFCI to a different location away from the source of the noise. An arc fault or a very small fault current might not be detected. An arc fault is a dangerous electrical condition that occurs when electricity jumps from one conductor to another. This can create a high-temperature arc that can ignite nearby materials and cause a fire. A very small fault current is a small amount of electricity that is leaking to ground. This current may not be large enough to trip the GFCI during self-testing, but it can still be dangerous. If you suspect that there is an arc fault or a very small fault current in the circuit, you should contact a qualified electrician to investigate. The reliability of self-testing is limited. While the self-test reset button on a GFCI can provide an indication that the device is functioning, it is not a comprehensive test of the entire system. It only tests the internal circuitry of the device and does not verify the ground path or other components of the electrical circuit. Therefore, it is important to test the GFCI with a ground fault tester on a regular basis to ensure that it is functioning properly. Now let's look at specific recommendations to address the problem. Firstly, inspect the wiring thoroughly. Carefully check the wiring connections to the GFCI and ensure they are secure and correct. Pay close attention to the line and load connections and make sure that the ground wire is properly connected. If you find any loose or incorrect connections, correct them immediately. Secondly, test with a ground fault tester. Use a ground fault tester to confirm that the ground path is complete and the GFCI is functioning properly. The ground fault tester simulates a ground fault and trips the GFCI if it is working correctly. If the GFCI does not trip when tested with the ground fault tester, it is likely defective and needs to be replaced. Thirdly, if the issue persists and the ground wire is confirmed to be intact, it is advisable to contact a qualified electrician to further diagnose and repair the problem. Electrical work can be dangerous, so it is best to leave it to the professionals. Finally, if all other causes have been eliminated, consider replacing the GFCI to ensure optimal protection against electrical hazards. GFCIs are relatively inexpensive and easy to replace, so it is a good idea to replace them every few years, or if you suspect that they are not functioning properly. To further elaborate on ground rods, it's important to understand their function and how they integrate into the grounding system. The grounding system is designed to provide a low impedance path for fault current to return to the source, which in turn trips the circuit breaker or fuse, disconnecting the power to the circuit. The ground rod is a critical component of the system, as it provides a direct connection to the earth. The ground rod is typically made of copper or copper-clad steel, and it is driven into the ground at least 8 feet deep. The top of the ground rod is then connected to the electrical panel with a heavy-gauge copper wire. If the ground rod is not properly installed, or if it is corroded, it may not provide a good enough ground connection. This can prevent the GFCI from tripping properly, and it can also increase the risk of electric shock. To check the ground rod, you'll need to visually inspect it to make sure that it is securely driven into the ground and that it is not corroded. You can also test the resistance of the ground rod using a ground resistance tester. A good ground rod should have a resistance of 25 ohms or less. If the resistance is higher than 25 ohms, you may need to install an additional ground rod or improve the existing ground rod. Here are some additional details regarding electrical noise and interference. Electrical noise can be introduced into the electrical system from a variety of sources, including lightning, radio transmissions, and electrical equipment. This noise can interfere with the operation of electronic devices, including GFCIs. Electrical noise can cause GFCIs to trip unnecessarily, or it can prevent them from tripping when they should. To mitigate the effects of electrical noise, you can try installing a noise filter in the circuit. A noise filter is a device that is designed to block electrical noise from entering the circuit. You can also try moving the GFCI to a different location away from the source of the noise. In some cases, it may be necessary to install a dedicated circuit for the GFCI to minimize the effects of electrical noise. Finally, replacing a GFCI is a relatively simple process, but it is important to follow the instructions carefully to avoid electric shock. Firstly, turn off the power to the circuit at the electrical panel. Secondly, remove the old GFCI from the wall box. Thirdly, disconnect the wires from the old GFCI. Fourthly, connect the wires to the new GFCI, making sure that the line and load wires are connected to the correct terminals. Fifthly, install the new GFCI into the wall box. Sixthly, turn the power back onto the circuit of the electrical panel. After you have replaced the GFCI, test it with a ground fault tester to make sure that it is working properly. It is also important to note that GFCIs are not a substitute for proper grounding. GFCIs are designed to protect people from electric shock, but they will not protect equipment from damage caused by electrical surges or other electrical problems. Therefore, it is important to make sure that all electrical circuits are properly grounded to protect both people and equipment. If you are not comfortable working with electricity, it is best to contact a qualified electrician to perform any electrical work. They have the knowledge and experience to do the job safely and correctly. Remember that electrical safety is paramount, and it is always better to be safe than sorry. Another important consideration is the type of GFCI being used. There are two main types of GFCIs: receptacle type and circuit breaker type. Receptacle type GFCIs are installed in place of a standard electrical receptacle, while circuit breaker type GFCIs are installed in the electrical panel. Receptacle type GFCIs are typically used to protect individual receptacles or small groups of receptacles, while circuit breaker type GFCIs are used to protect entire circuits. The type of GFCI that is best for a particular application depends on the specific needs of the application. If you are only trying to protect a few receptacles, a receptacle type GFCI may be the best option. However, if you are trying to protect an entire circuit, a circuit breaker type GFCI may be a better choice. It's also worth mentioning the importance of regular testing. GFCIs should be tested monthly to ensure that they are functioning properly. To test a GFCI, simply press the test button on the GFCI. This should trip the GFCI and cut off power to the circuit. If the GFCI does not trip when you press the test button, it is likely defective and needs to be replaced. After testing the GFCI, reset it by pressing the reset button. This should restore power to the circuit. If the GFCI trips repeatedly, there may be a ground fault in the circuit. In this case, you should contact a qualified electrician to investigate. In addition to monthly testing, GFCI should also be tested after any electrical work is performed in the circuit. This will ensure that the GFCI is still functioning properly after the work has been completed. Also be aware of nuisance tripping. Nuisance tripping is when a GFCI trips for no apparent reason. This can be caused by a variety of factors, including electrical noise, faulty appliances, and loose wiring connections. If a GFCI is tripping frequently, it is important to identify the cause of the tripping and correct it. If you are unable to identify the cause of the tripping, you should contact a qualified electrician to investigate. And consider arc fault circuit interrupters or ASIs. ASIs are devices that are designed to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. Assays are typically installed in the electrical panel, and they are designed to trip the circuit breaker if an arc fault is detected. Assays are becoming increasingly common in new homes, and they are often required by building codes. While GFCIs protect against ground faults, assays protect against arc faults. Both types of devices are important for electrical safety. Also be mindful of the age of the GFCI. GFCIs have a limited lifespan, and they should be replaced every 10 to 15 years. Over time, the internal components of a GFCI can degrade, which can reduce its effectiveness. Replacing GFCIs on a regular basis will help to ensure that they are functioning properly and providing the protection that they are designed to provide. Additionally, consider the environment where the GFCI is installed. GFCIs that are installed in damp or wet locations are more likely to fail than GFCIs that are installed in dry locations. If a GFCI is installed in a damp or wet location, it should be a weather-resistant GFCI. Weather-resistant GFCIs are designed to withstand the effects of moisture, and they are less likely to fail. Also be aware that GFCIs can be affected by power surges. Power surges are sudden increases in voltage that can damage electronic devices. If a GFCI is subjected to a power surge, it may be damaged and no longer function properly. To protect GFCIs from power surges, you can install a surge protector. Surge protectors are devices that are designed to absorb power surges and prevent them from reaching electronic devices. So, to summarize the key points, several factors can cause a GFCI to exhibit the symptoms described. An open ground wire, incorrect wiring, a defective GFCI unit, the ground rod issue, electrical noise, or an arc fault can all contribute to the problem. Remember that the self-test function is not a comprehensive test of the system. Inspect the wiring, test with a ground fault tester, and contact a qualified electrician if needed. Replacing the GFCI is an option if other causes are ruled out. Also, consider the type of GFCI being used, test them monthly, and be aware of nuisance tripping and the age of the GFCI. By systematically investigating these potential causes and following the recommendations, you can effectively troubleshoot and resolve the issue, ensuring the safety of the electrical system.